This is 11.3, Areas of Circles and Sectors. Scan the text under the Now heading. List 2 things you will learn about areas of circles and sectors. The first under the Now heading says how to find the area of circles. And the second says how to find the area of sectors. It says write the correct term next to each definition. So these are review from 10.2, 11.1, and 11.2, so the last few sections. Any side of a triangle is called the base of a triangle. An angle with a vertex in the center of the circle that contain 2 radii is called the central angle because it comes from the center. The length of the altitude drawn to any base. Remember, altitude means it forms a right angle, so this would be the height of a triangle. The distance between the 2 bases of a trapezoid. So again, the thing that connects those 2 bases is going to be the height of a trapezoid. A portion of a circle defined by 2 endpoints. So if you need to draw it out to remind yourself, if this is my circle and I'm defining a part of the circle defined by 2 endpoints, that's called an arc. And then lastly, any side of a parallelogram would be the base of a parallelogram. So the only new vocabulary word we have in this section is called the sector of a circle. It says define the sector of a circle in your own words. Well, if I were to shade a sector of a circle, it's this right here. The exact definition in the book reads, a sector of a circle is a region of a circle bounded by a central angle, which would be here, coming from the center, and its arc, which would be here, the edge of the circle. I think the easiest way to remember a sector of a circle is it's a slice of the circle. It looks like a slice of pizza. So, area formula for a circle, we'll write this down. It's going to be pi times the radius squared. Not to be confused with circumference. Circumference was 2 pi r, and the units were not squared. Here, pi r squared, my r is squared, so my units will be squared. That's how I remember the difference between the circumference formula and the area formula. It says find the area of each circle, round to the nearest tenth. So in number 1, they give us the distance all the way across the circle, or the diameter. If the diameter is 18, I know the radius is half of that, so it's going to be 9. I can plug it into my formula. Area equals pi times the radius squared. I'm going to end up with 81 pi, or pi times 81, which gives me 254.3 centimeters squared. In number 2, they gave me my radius, so I can go straight to plugging it in. Area equals pi times the radius squared. 7 squared is 49. Multiply it by pi and round to the nearest tenth to get 153.9 inches squared. Use the organizer below and fill in the parts of the proportion that can be used to find the area of a sector. Okay, so we know that a sector is a slice of pizza. It's a part of a circle. So if I were to solve for this, I could say area of the whole circle is pi r squared. If I take that ratio and I set it equal to x over 360, where x is the measure of that central angle I get the ratio of the area A of a sector to the area of the whole circle, pi r squared, is equal to the ratio of the degree measure of the intercepted arc to 360. This first ratio represents it in terms of its area. This one represents the portion of the circle in terms of the degrees of the central angle. So if I needed to solve for A, I can cross multiply. By cross multiplying, I would get 360 times A equals x pi r squared. Divide both sides by 360. And my area formula for a circle is x times pi times r squared over 360. Use the completed portion or proportion to find the area of the shaded sector. Round to the nearest tenth. So in this case, this is the slice of pizza they're asking me to find the area for. I see that x, or my angle, is 55, and r, or my radius, is 4. So plugging into my formula, I would do x times pi times r squared divided by 360. I'll multiply everything on the top and divide by 360 to find 7.7 units squared. So it says a good way to remember something is to explain it to someone else. Suppose your classmate is having trouble remembering the difference in the circumference and the area formula. So I kind of said this at the very beginning. Circumference is 2 pi r. The units will not be squared. Area is pi r squared. The r is squared, so you'll notice the units have to be squared. So in this case, what's happening to the r will match the appropriate units for circumference or for area. So that's the end of section 11.3. I'd like you to head back to the first page of your notes so we can fill in these area formulas. The first one we have is for the circle. Area equals pi r squared, where this would be my radius. And the second one is for the sector. Area equals x pi r squared over 360, where x is my measure in degrees and r is my radius. Now you're ready to complete section 11.